In this video, I am going to find the partial fraction of x plus 5 divided by x cubed minus 3x. So let's go ahead and simplify it slightly. So x plus 5 divided by, I could factor out an x in the denominator. That's going to give me x squared minus 3. So in essence, I'm going to break this expression into two pieces, into two fractions. So the way you do this is as follows. So x plus 5 over x times x squared minus 3, that is going to be equal to, I'm going to write it as a over x plus, now you have x squared minus 3. When you have a square term, what you have to do, you have to rewrite it as this. So you have to have an x term with constant b times x plus a constant c. So x squared minus 3 is going to be in the denominator. In general, if you have a term something like that, ax squared plus bx plus c, okay, in the denominator, what you'd want to do on the numerator, you're going to put something like this, an x term with a constant. So let's say it's c1 times x plus c2. So that's the general structure for doing it. And theoretical justification for that is a bit more involved. So let's go ahead and just try to solve it, okay? All right, so let's go ahead and multiply both sides of this equation by x times x squared minus 3. So x times x squared minus 3. And then x times x squared minus 3. Now cancellation will happen. These two and these two are going to cancel out on the left, and you're going to be left with x plus 5 on the left, and on the right this and this is going to cancel out. That's going to give me a times x squared minus 3a, right? Then this and this is going to cancel out. That's going to give me x times bx, which is bx squared plus c times x. Now I'm going to rewrite it. X plus 5 is equal to a plus b times x squared. So I'm combining the like terms. Then plus c times x plus negative 3a, which is the constant term. Now I'm going to do something slightly different here. So I'm going to put a 0 times x squared. And I will tell you why I'm doing this. 0 times x squared is just 0. I'm adding 0 to left side, which should not have any impact on the equation. Now, the reason I did that is to make sure that I compare apples to apples. This is an equation. It says that left-hand side must be equal to right-hand side, and we are dealing with polynomials. So the coefficients must be the same for both sides, okay, corresponding coefficients. So coefficient of the square term on the left is 0. Coefficient on the square of the square term on the right is a plus b. So that tells me right away a plus b must be equal to 0, okay? Then coefficient of x on the left is 1, right? 1 times x is just 1. Coefficient of the x on the right is c. So c must be equal to 1. And then constant term on the left is 5. The constant term on the right is negative 3a. So that tells me that negative 3a must be equal to 5. Or if I solve for a, that's going to give me a is equal to negative 5 over 3. I found c is equal to 1, a is equal to negative 5 over 3. And a plus b is equal to 0. That tells me b is just negative a, which is just 5 over 3, right? So I found a is equal to negative 5 over 3, b is equal to 5 over 3, and c is equal to 1. So these are the numbers that I am looking for. These are my values of a, b, and c. Now if I rewrite it, what do I get? So x plus 5 over x cubed minus 3x, which is the same as x plus 5 over x times x minus 3, right? That is equal to a over x. So a over x. So it's going to be negative 5 over 3x plus bx plus c. So b is 5 over 3, right? So b is 5 over 3. So 5 over 3x plus c is equal to 1. So it's going to be 1. And that is divided by x squared minus 3. Now, if you really want to simplify it, you could go ahead and simplify it a little bit. If you do that, you're going to get the following. So negative 5 over 3x plus, so it's going to be 5x plus 3, right? Divided by 3 times x squared minus 3. This is how you do the partial fraction. I hope that this discussion was helpful. Thank you so very much.